Hello everyone and welcome to a new showcase video. Today with live commentary and more detailed instructions about how to install the Dynex SDK and link your marketplace account. Today we are showcasing how to use the Dynex neuromorphic quantum computing cloud to solve an aircraft loading optimization problem. Now you might be wondering, what is aircraft loading optimization and why is it important? In simple terms, it allows and enables airliners to make better and more informed choices on which part of the available payload to take on board and where to place them on the aircraft. This is vital for airliners as they are always striving to maximize their revenue while operating at the lowest possible costs. When we are performing a computation like this, we need to take into account a number of limits, such as the maximum payload capacity of the aircraft, its center of gravity position, and the shear fuselage limits. Apart from a number of variables which are related to the cargo itself, such as the sizes of the cargo containers, how much normalized space they occupy, and the weight or the mass for the cargo containers, for example. So first I am going to install the Dynex SDK repository from our GitHub. This repository has lots of examples mentioned, use cases which everyone can use. I'm going to download this zip file. And I'm going to extract it. Cool, so now we have this here. This is our dynex.ini file. I will show you real quickly what that is. So when we are using the Dynex platform, the marketplace obviously needs to know, or the SDK needs to know which account is using it. So to identify that, we have a dynex.ini file, which you can obtain via your marketplace account, which has your API key and your API secret, which again tells the SDK that you are the user who is using it. So I'm going to place these two files into the SDK folder. And then we will proceed to the aircraft loading optimization problem. So firstly, I need to make sure that I'm in the right folder, which in my case is this one. So now we're there, I'm going to make sure that Dynex is properly installed. You can do that, or I install the Dynex SDK properly, which you can do by calling pip install Dynex. As you can see here, the SDK is already installed on my machine, but I thought it was worthwhile to show how it's done. Then we proceed to our Python environment. We import Dynex. Then we are going to test if everything works as it should. As you can see here, it's running a couple of sample tests to make sure everything is working correctly, which in our case is the case. So that's cool. We can now proceed to the actual optimization problem. We are going to import a few dependencies first. What's mentioned here are a number of variables which we are going to include in the computation, such as the maximum payload capacity of the aircraft, the number of different weights of the cargo, the available spaces, and the total amount of cargo, from which we are going to see which one is most optimal to take on board. Cool, now we are going to generate a QBO formulation, which is done. Perfect. So as you can see here, we're going to perform the computation on mainnet. I'm also going to give it a description to make sure we can identify it easily when we're checking out the marketplace in a bit. We're going to use 1000 quantum circuits this time. So that's it. Now we're going to run it on mainnet. Oh, my bad. As you can see here, it's submitting the job to the network. We have job 8162. So if we now go to the marketplace, we should be able to see that. (8162) is ongoing at the moment. Last time I did this computation, it took about 2 minutes, so we'll be back shortly. As you can see now, the job is completed. The job itself took 1 minute and 33.7 seconds. Now we're gonna import the results to show us a visualization of the results. Now we're going to import a few more dependencies. So this is the visualization of the results of our computation file. Given the amount of variables we entered, this is how an airliner should load up this specific aircraft to be as optimized as possible. And that's it for today, guys. I hope you all enjoyed this showcase video. Expect to see more showcase videos in the near future, and I'll catch you at the next one. Thanks for watching. Have a good day. Cheers.